It is indeed possible for a company to possess jurisdiction over its own plant under specific conditions. However, it's crucial to understand that this authority doesn't grant them the freedom to disregard established electrical safety codes and standards. Based on the information presented, if the municipality or county where the plant is situated lacks a dedicated code enforcement division, the company assumes the role of the governing authority. This designation carries the responsibility of ensuring that all electrical installations within the plant adhere to the National Electrical Code, or NEC, and any other relevant codes and standards. It's important to note that the providing utility company retains authority over the safe interconnection of its system to the customer's system. This implies that the utility company can mandate the implementation of particular safety measures, such as the installation of a field-mounted disconnect for crane rails. Even when a company is recognized as the governing authority, engaging a certified inspector to evaluate electrical installations remains a prudent step. This practice helps confirm that the installations are both safe and compliant with all relevant codes and standards. To accurately determine the specific requirements for a particular plant, it's advisable to communicate directly with the local municipality, county, and utility company. These entities can furnish the most current information concerning applicable codes and standards. The National Electrical Code, or NEC, plays a vital role in the electrical industry. The NEC is not a federal law. Instead, it serves as a comprehensive standard for electrical safety in the United States. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect changes in technology and best practices. While the NEC itself isn't law, it's widely adopted by state and local jurisdictions, becoming a legal requirement for electrical installations. The NEC covers a broad range of electrical topics. Firstly, general wiring and protection focuses on safe wiring methods, overcurrent protection, and grounding. Secondly, wiring methods and materials specifies acceptable types of cables, conduits, and other wiring components. Thirdly, equipment for general use outlines requirements for appliances, luminaires, and other electrical equipment. Fourthly, special occupancies addresses unique electrical needs in hazardous locations, healthcare facilities, and other specialized environments. Fifthly, special equipment covers electrical systems for elevators, swimming pools, and other specific types of equipment. Chapter 9 contains tables and examples that provide detailed guidance on conductor sizing, conduit fill, and other calculations. The NEC employs a system of articles, sections, and tables to organize its requirements. Articles are broad topical divisions, sections provide specific rules and regulations, and tables offer data and calculations. Firstly, understanding these organizational elements is crucial for navigating the code effectively. Secondly, the NEC emphasizes the importance of using listed or labeled equipment. Thirdly, this means that the equipment has been tested and certified by a recognized testing laboratory, ensuring that it meets safety standards. Grounding and bonding are essential for electrical safety. Firstly, grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing an electrical shock. Secondly, bonding connects metallic parts of an electrical system to create a low impedance path for fault current. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from excessive current, which can cause overheating and fires. Firstly, these devices are designed to interrupt the flow of current when it exceeds a safe level. Secondly, it's crucial to select the correct size of overcurrent protection device for the circuit it's protecting. Wiring methods specify how electrical conductors should be installed and protected. Firstly, common wiring methods include conduit, cable, and surface raceways. Secondly, the NEC provides detailed requirements for each wiring method, including conductor fill, support, and protection from physical damage. The NEC addresses specific requirements for different types of occupancies. Firstly, healthcare facilities have stringent requirements for patient care areas to prevent electrical shock hazards. Secondly, hazardous locations, such as those where flammable materials are present, require specialized equipment and wiring methods to prevent explosions. The NEC is not a design manual. While it provides minimum safety requirements, it's not intended to be a comprehensive guide for electrical system design. Electrical engineers and designers must use their expertise to create safe and efficient electrical systems that meet the specific needs of a building or facility. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC. The AHA can be a local building inspector, a state electrical inspector, or another qualified individual. The AHA has the authority to interpret the NEC and to require compliance with its provisions. The NEC is constantly evolving to keep pace with new technologies and safety concerns. The NFPA publishes revisions to the NEC every 3 years, and it's important for electrical professionals to stay up to date with the latest changes. Continuing education courses, industry publications, and online resources can help electrical professionals stay informed. Understanding the NEC is essential for anyone working with electricity. Firstly, electricians, electrical engineers, and building inspectors all need a thorough knowledge of the NEC to ensure electrical safety. Secondly, by following the NEC, electrical professionals can help protect people and property from the hazards of electricity. In addition to the NEC, other codes and standards may apply to electrical installations. Firstly, the International Building Code, or IC, contains requirements for electrical systems in buildings. Secondly, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment. The IEE, the Institute of Electrical and Electronics Engineers, develops standards for electrical power systems. Firstly, understanding these additional codes and standards is important for ensuring comprehensive electrical safety. Secondly, the NEC is a valuable resource for electrical professionals. By understanding its requirements and staying up to date with its changes, one can help to ensure electrical safety in buildings and facilities. The NEC provides tables for calculating wire sizes based on ampacity, the allowable current carrying capacity of a conductor. The ampacity of a wire is affected by several factors, including the wire's material, its size, its insulation type, and the ambient temperature. Table 310.15b16 and associated tables in the NEC are frequently used for determining ampacity. These tables provide ampacity values for various conductor types based on their size and insulation rating, assuming specific ambient temperature conditions. Correction factors are applied when the ambient temperature exceeds the values listed in the table. Adjustment factors are applied when multiple current-carrying conductors are bundled together in a raceway or cable, as heat buildup can reduce the ampacity of each conductor. Voltage drop is a critical consideration in electrical circuit design. Excessive voltage drop can cause equipment to malfunction, reduce the brightness of lights, and even damage electrical components. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using formulas that take into account the conductor's length, current, and resistance. Increasing the conductor size or using a conductor with lower resistance can reduce voltage drop. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or ASIs, protect against fires caused by arcing faults. ASIs detect the unique characteristics of arcing faults and interrupt the power before a fire can start. ASIs are required in many locations, including bedrooms and living rooms. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD divert the surge current away from sensitive equipment, preventing damage. SPD are available in various types, including whole-house SPD and point-of-use SPD. Electrical panels, also known as load centers or breaker boxes, distribute electricity throughout a building. Electrical panels contain circuit breakers or fuses that protect individual circuits from overcurrents. Electrical panels must be properly sized to accommodate the building's electrical load. Conduits are raceways used to protect electrical wiring. Conduits are available in various materials, including metal and plastic. Conduits provide physical protection for wiring and prevent the spread of fire. Cables are assemblies of two or more conductors within an outer jacket. Cables are available in various types, including non-metallic sheath cable and armored cable. Cables are commonly used for residential wiring. Lighting is a critical aspect of electrical design. Lighting systems must provide adequate illumination for the tasks being performed. Lighting systems should be energy efficient to reduce electricity consumption. Different types of lamps are available, including incandescent lamps, fluorescent lamps, and light-emitting diodes, or LEDs. Electrical safety is paramount. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. Follow all applicable electrical codes and standards. If you are not qualified to perform electrical work, hire a licensed electrician. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that wiring must be properly supported, connections must be tight, and equipment must be installed according to the manufacturer's instructions. Electrical equipment must be accessible for maintenance and repair. Adequate working space must be provided around electrical equipment. The electrical equipment must be protected from physical damage. The NEC provides requirements for the labeling of electrical equipment. Electrical panels must be labeled to identify the circuits they serve. Disconnect switches must be labeled to indicate the equipment they disconnect. Warning signs must be posted to alert people to potential electrical hazards. The NEC addresses specific requirements for swimming pools and spas. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits serving swimming pools and spas. Bonding is required to equalize the potential between metallic parts of the pool or spa. Underwater lighting must meet specific safety standards. The NEC provides requirements for electrical systems in healthcare facilities. Isolated power systems are required in operating rooms and other critical care areas. Ground fault circuit interrupters, or GFCIs, are required in patient care areas. Emergency power systems must be provided to supply power to essential equipment during a power outage. The NEC addresses specific requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dusts are present. Electrical equipment used in hazardous locations must be specially designed to prevent explosions. Different classes and divisions of hazardous locations are defined in the NEC. The NEC provides requirements for renewable energy systems such as solar photovoltaic systems and wind power systems. These systems must be installed in accordance with the NEC and other applicable codes and standards. Qualified personnel must perform the installation of renewable energy systems. The NEC is a complex and comprehensive document. It's essential for electrical professionals to have a thorough understanding of the NEC to ensure electrical safety. Continuing education, industry publications, and online resources can help electrical professionals stay informed about the NEC. Municipalities and local jurisdictions often have amendments to the NEC that are specific to their area. It is crucial to consult with the local authority having jurisdiction or OJ to determine the specific electrical requirements for a given project. Amendments may address unique environmental conditions, local construction practices, or specific safety concerns. The permitting process ensures that electrical work is reviewed and approved by the AHJ before construction begins. Permits are typically required for new electrical installations, alterations to existing systems, and equipment upgrades. The permitting process helps to ensure that electrical work complies with the NEC and local amendments. Inspections are conducted by the AHJ to verify that electrical work has been performed in accordance with the NEC and approved plans. Inspections are typically performed at various stages of construction, such as after rough wiring and before covering up wiring. Addressing any deficiencies identified during inspections is crucial to obtain final approval. Unapproved modifications or installations can create hazardous conditions and violate electrical codes. It is essential to consult with a qualified electrician or the AHA before making any changes to an electrical system. Tampering with electrical equipment can void warranties and insurance coverage. Regular maintenance of electrical systems helps to prevent problems and extend the life of equipment. Maintenance tasks include inspecting wiring, tightening connections, and testing overcurrent protection devices. Keeping electrical panels clean and free of obstructions is also important. Working with electricity can be dangerous. It is essential to follow all safety precautions and use appropriate personal protective equipment, or PPE. If you are not qualified to perform electrical work, hire a licensed electrician. The NEC provides guidance on energy-efficient electrical design. Using energy-efficient lighting, appliances, and equipment can reduce electricity consumption and save money. Designing electrical systems to minimize voltage drop can also improve energy efficiency. Smart home technology can enhance electrical safety and convenience. Smart smoke detectors can alert occupants to a fire even when they are away from home. Smart lighting systems can be controlled remotely and can be programmed to turn on and off automatically. Smart outlets can monitor energy consumption and can be used to control appliances remotely. Electric vehicle, or EV, charging stations are becoming increasingly common. The NEC provides requirements for the installation of EV charging stations. Proper grounding and overcurrent protection are essential for EV charging stations. The location of the EV charging station must be carefully considered. Ensuring that the electrical system is adequate to handle the additional load of the EV charging station is also important. It's crucial to select electrical equipment that is appropriate for the intended use and environment. Equipment intended for outdoor use must be rated for wet locations. Equipment used in hazardous locations must be specifically designed for those environments. Equipment must be properly sized to handle the electrical load. Improperly sized or installed electrical equipment can create safety hazards. The National Electrical Code Article 90.4 permits the AHA to waive specific requirements or permit alternative methods. Granted, the AHA is assured that equivalent objectives can be achieved.